Okay, tonight we're continuing with the idea of solving linear equations and using the properties of equality in order to do so. So this is going to be taking the information from lesson 1 and lesson 2 and combining them into some more complex equations. All right, so this publisher breaks down how to solve linear equations into these six steps, with the sixth step always being or whatever the final step is, always being to check your solution into your original equation to make sure that you get it right. The easiest way to prevent getting an answer wrong needlessly is to take the solution that you had and plug it back into the original equation. So I'm not going to say all of these steps. You guys have access to that. So if you need to pause this right now in order to copy those down, you can do it that way. Or you can access the slideshow on MathXL and copy it down from that. All right, but I'm not going to waste time reading through all of these. So starting in immediately into examples, all right, if your original equation in this case is 17 minus x plus 3 equals 15 minus a negative 6, all right? So you don't have anything that you need to divide both sides by. So the first thing you're going to want to do is you're going to want to combine like terms. Okay, and your like terms in this case being your 17 and your 3 on the left side and your 15 and negative 6 on the right side. All right, so you have 17 plus 3, which is going to be 20, minus x, equals, and you have 15 minus a negative 7, which is the same thing as saying 15 plus 6, because this negative will apply through, and we'll turn this 15 minus 6 minus a negative 6 into a 15 plus 6. Okay, so that is going to be 21. All right, and then your next step is going to be going back to trying to get the x by itself. All right, so to prevent having to do multiple steps, you can subtract the 20 from both sides. Okay, subtract 20 from both sides, and that leaves you with a negative x equals a positive 1. All right, you still have this negative here though, which means the x is not completely by itself. So to get the x completely by itself, you divide both sides by the negative 1, which is implied by this negative sign in front, and you get the x equals a negative 1. Okay? All right. So this next problem you have 7 times x minus 3 equals 9x minus 7. Okay, your first step in this situation is going to be to distribute this 7 through the equation, through what's inside the parentheses. So that would give you a 7x minus 21 equals a 9x minus 7. Right, and I told you last time that the easiest way is to make sure you try to keep your x's positive. So I would subtract the 7x from both sides, which would leave you with a negative 21 equals positive 2x minus 7. Okay, and then you're going to add the 7 to both sides. All right, and you would get positive 2x over here. Sorry, as you guys know, I'm still trying to get over a cold. All right, so you have the negative 21, and you're going to add the 7 to that, and that is going to give you a negative 14. All right, the x is still not by itself, so you need to divide both sides by 2, divide both sides by 2, and that leaves you with a negative 7 over here equals a positive x. Okay, so that's going to be your solution. All right, so what do you do if you have a fraction? All right, the first thing that you do when you have a fraction is you don't freak out because there's a fraction. All right, so in this case, you have 1 plus 3/5 a equals 8. Okay. The easiest way to start this is instead of dealing with the fraction, which is here, get this to the other side of the equation. So get the +1 to the other side of the equation. That's where I would start, all right? So you're going to subtract 1 from both sides, which would leave you with 3/5 a equals 7, okay? And then your next step from there is now you have to get rid of this fraction right here, all right? And if you remember from section 2, the best way to do that is to multiply by the reciprocal, okay, which would be 5/3. You multiply both sides by the reciprocal, which would be 5/3 over here, right? Your fraction cancels out, becomes a value of 1. So that's going to be a equals 7 times 5/3. 7 times 5 is going to be 35/3. Can you reduce that? Does 3 go into 35 at all? Not really. Okay, so that's going to be your solution. All right, if your base down here is prime, the best way to know if you can reduce this at all is if your prime number on the bottom down here goes into the top number, and in this case it does not. So that's going to be your simplified solution, is a equals 35/3. Okay. This next one is a little bit different. Okay, so you have a 3 times y plus 3, all of that over 5. Okay, and that's going to equal 2y plus 6. Okay, so the first thing you need to do is you actually need to get rid of this fraction right here first. All right, so what you're going to multiply everything by is you're going to multiply both sides by 5/1 to get rid of this 5 down in the denominator over here. So you multiply this side by 5 and this side by 5. Your 5 goes away, and you're now left with 3 times y plus 3 equals 5, distribute the 5 through, okay, equals 10y plus 30. All right, you're going to want to subtract the 3y from both sides to keep your variable a positive number, and that would leave you with a positive 7y. Subtract the 30 from both sides. Subtract the 30 from both sides. That's going to leave you with a negative 21. You still don't have the y by itself, so you divide both sides by 7. Divide both sides by 7. And y is going to equal a negative 3. Okay, so your first step in dealing with this is to get rid of this number down here on the bottom. All right. Anytime you have an equation that looks like this, your first step should be to multiply each side by the number that you see on the bottom so that you get rid of this fraction on this side of the equation. All right, it will make it a lot easier for you to solve it. All right, recognizing identities and equations with no solutions, okay? So what we're dealing with and what we're talking about when we say an identity, all right, when we say an identity, what we're looking at is we're looking specifically at when a value on one side of the equation equals a value on the other side of the equation, right? So 0 equals 0 is an identity. 2x plus 5 equals 2x plus 5. That's an identity too. So if at any point you get an equation where on both sides of the equal sign it looks identical, you're going to know immediately that your solution is going to be all real numbers. Okay? So what you have in this equation is you have 3x minus 7 equals 3x plus 1. Okay, you distribute the 3 through on this side. That's going to be your first step. So you get 3x plus 3 equals 3x minus 7. Okay, you're going to subtract 3x from both sides. Okay, that doesn't make anything go away. This now just becomes a 0. All right, equals 0 plus 3. All right, you're going to add the 7 to both sides because you want it to be positive. It will make your life easier, which leaves you with a 0 over here. 3 plus 7 is 10. 0 equals 10. Does 0 equal 10? This is not actually a trick question. 0 does not equal 10. Okay, so in this situation, you have something that is not true. All right, so if at any point, if you have things that equal each other, you get all real numbers. If you have something that's not true, okay, once you solve it out, you're going to end up with no possible solution. All right, sorry, my trackpad is apparently having issues right now. All right, so your answer is going to be no solution. So it's at that point that you would select, you would go, wait, what do I do? You don't have any answer. All right, it's going to be no solution. Okay, so this is slightly different. You have (5x minus 5) equals, first step, distribute that through. All right, so I'm not even going to write that out. I'm just going to distribute it. 2x plus 2 plus 3x minus 7. You're going to have to combine like terms on this side of the equation. Okay, combine like terms. So you would get 5x minus 5 over here. Combine like terms, 2x plus 3x is going to be 5x. And you have 2 plus a negative 7 is going to be a negative 5. You don't have to solve this any further. All right, you can already see that on this side of the equation and on this side of the equation, they look identical. All right, if at any point they look absolutely identical like this does, you can immediately say that your solution is going to be all real numbers. All right, so this is where some of you guys got hung up earlier. So just make sure that if you at any point you get a statement like this where it's identical, you can stop right away and you can just put in that it's all real numbers. You can't do that with no solution. You have to solve it through until you get to the end where you have something like 0 equals 10. You know 0 does not equal 10, so your answer to that equation is going to be no solution. All right, so that's all you really need to worry about with this. And from there, you should be all set to do the homework for tonight.